Now, this video we're going to look at how to factorise by what we call completing the square. So it's another form of factorising, because you can't always do the normal double bracket form. Sometimes you can only do this one. So what we're going to start off by doing is looking at just the first two terms, the terms with the x's in. And we're going to do what this suggests. We're going to draw a square and complete it. Something's going to be missing and we're going to fill it in. So split your square into 4 sections, and I've deliberately made them slightly different sizes just to represent that these aren't the same value. So it's a multiplication grid, so we're going to have x squared in one. Now you've got to think of this. It's a square, so this length here must be the same as this length here. And what I'm trying to do is make the total of these two equal to this 6x. So I can't put a 5 and a 1 or a 4 and a 2, because it would mean that this length would be different to this one, and therefore not a square. So I have to split this term in half, and that's what we have. So on the outside, it has to be x times x to make x squared, and x times 3 to make 3x. And you can see here there's a cell we need to complete. So 3 times 3 is 9. So what I've just done, I've taken these two terms and I've completed the square on them, and when I do that I add a 9. But in my question it was a 10. And when we factorise, we do it to write an equivalent expression. So this and this has to be the same, but at the moment you can clearly see that it's not. So what do I need extra? Of course I need to plus a 1 to make it equal the same. Now here comes the final part. This is technically the area of this square. So instead of writing the area, I can write the calculation. I could say, well, it was this squared, this times this, and that is x plus 3. So instead of writing all of this, I can write it in this form as x plus 3 all squared. And of course I need to chuck on the 1 at the end. And there we have it. I have now written this in a factorised form called completing the square. I'll show you another one. So just the first two terms, draw my square, split it up, x squared in the bottom left, and because it's a square we're going to half this and put that in each one. X and x, and x times what is 5x? Well, that's a 5 and a 5. Now this one cell here to complete the square would be 5 times 5, which is 25. So now I'm going to rewrite all of this out. So we need to write an equivalent expression when we factorise. So here we have this, we complete the square, we have 25. What's missing? An extra 2. Now to get it in this form, instead of writing all of this, which is the area of this square, we can say, well, it's this squared. So the length of the square squared. Chuck on my plus 2 at the end and we are done. So why not try and pause the video now, and when you're ready, play it. So you'll notice on this one I've changed this to a negative, suggesting that it should be a negative. And they'll probably do that in your test as well. So first two terms, split this in half, so it's 2x and 2x. Fill in the outsides. When I complete the square, that will be a 4. So I'm going to rewrite all of this, so x squared, 4x plus 4. But this now is slightly different. I've added a 4 when I've completed the square, but my original expression had to be a 3. So to make this equivalent, I've got to take away 1. I can write this in this form. The length of the square squared, so that's x plus 2 squared, and this time it's a minus 1. Let's do another one. Again, pause it. You'll see this time there is a minus 4. We haven't had any of these yet. So I should have technically changed this, but it doesn't really matter. So first two terms, complete the square, but we're halving this now, so it's going to be minus 2x in both, so it makes minus 4x in total. So what times x is minus 2x? Well, that of course is minus 2. And be careful with your negatives, but when you square a number, irrespective of whether it's positive or negative, it's always going to have a positive outcome, which is 4. So let me rewrite this. So it's going to be these two, but when I complete the square, I add a 4. It needs to be 9 to keep it equivalent, so I need an extra 5. Instead of writing all of this, I can write this squared, so x minus 2 squared plus 5, and there we have it. I've got another one for you. So this one's slightly quicker. So minus 3 in both. Minus 3 squared is 9, so write that out. But to go from 9 back to minus 12, I have to do quite a big subtraction. I have to take away 21 at this time. Rewrite this as the length of the side squared, so it's x minus 3 squared, chuck on my minus 21. So that's it for this video, and in the next one I'm going to chuck on a coefficient here to make it slightly